Okay, so first thing, a quick remark about PLQ, since we have been talking about PLQ already. PLQ number 2 is going to come out next week. I was going to release one this week, but then I realized we have the GQ due, we have the IE due at the end of the week, so that's enough for this week, okay? But next week we'll have another PLQ, and then we should have, if my planning is right for the rest of the semester, we should have a PLQ about every week until the end of the semester, okay? Just to give you a heads up. As far as jumping back into the lecture goes, we are going to start by finishing some unfinished business, I guess. So we were working last time on this file here. Well, not exactly this file, but this exercise here, where we have our main that creates a bunch of audiobooks, and then we add two different implementation. Here's the first one, audiobook playlist, two different implementation of an audiobook playlist. So the first one was basic, featured a constructor and an add method, and you saw how easy it was to write the add method, because pretty much what we're doing, most of what we are doing is, well, let's tell the array list to figure it out. And then if we do some bookkeeping on the side, yes, we handle it ourselves. And then we made another version of the class, and this version inherited from the previous version, and it added a few features. The first feature it added was the get total, actually that's not this one, that's that one, the toString by narrator. We wrote it together during the live coding. And then I asked you to finish up the other method that it was supposed to add, which was get total duration by narrator. So if you have had any problem with it, here's the solution. If I put both of them side by side, you see the same pattern, right? It is exactly the same pattern. We have the same iteration pattern. We use the same tool to iterate the for each loop. We use the same conditional to check, if we're dealing with the narrator that we have been passed as parameter, yes or no. And then only thing that changes is where do I perform my job? Where do I accumulate something? In the above here, I accumulate durations that I obtain by calling a.duration. And in the version below, I accumulate description as string that I obtain by calling a.toString. So this is why I left it as an exercise. It's really a direct mapping of the one we did in class. I mentioned when we started this, I mentioned that there was one more thing I wanted to do with this example. I wanted to inherit from the class array list. We are going to do that together right now as live coding. Once we are done doing it together, you should be able to complete the 3 last practice exercise for the module. And then we are going to have new practice exercise for the rest of the module as soon as we start polymorphism. But you will be set up for all of the practice exercise that I have released so far. You are going to see how simple that is. However, pay attention. It's simple, but this is where we are going to know if you really understand the stuff or not. So if it doesn't click immediately, that means that there was something you were misunderstanding before, and now that we are looking at a slightly more complex example, it's kind of like falling apart. Don't worry. This is exactly how learning works, okay? You push your understanding until you don't understand anymore, then you make an effort, you understand, and now you have a better understanding. All right, so let's take a look at the code. And we are going to jump at the end of the code. We are going to add another class. So the goal here is I want an audiobooks playlist 2. So I don't want that Promax audiobook playlist. I don't care about those extra features. I want to go back to audiobook playlist, okay? But I want to make a second version. So I could call it audiobook playlist v2 version 2, right? I want to make another version of that class. It's not going to inherit from it. It's just another implementation that I make in parallel. But now the constraint is inside this class, I'm going to have my int total duration, so private int total duration, just like before. But I'm not going to have a list. In the previous class, I had a list attribute. Okay, that list attribute was of type array list of audiobook. Well, that's composition. That's inside a class, I declare an attribute which type is another class, so I say that I compose between the two classes, okay? One contains the other. I don't want to do that anymore. What I realized is with the extends keyword, I can extend any class. And so far, all I've been doing is extending class that I wrote myself, which, granted, most of the time this is what we're going to do, okay? But nothing prevents me from trying to extend the class ArrayList. How would I write it down? Class audiobook playlist v2 extends, what would I write here? Yeah? The ArrayList what? Yep. Okay. So, I just needed a starting point. Now let's reshape it. Audio extends ArrayList. Yes. Do we need the angular bracket? Yes. Do we need the parentheses? No, because we are not going to call a constructor here. It's not like we are doing new ArrayList, blah, blah, blah. If we do new ArrayList, yes, definitely we need those parentheses because we are calling a constructor to finalize the object. Here, I'm just stating this class extends that other class. So when I put the name of another class, like for example, if I add here, I don't know, audiobook, doesn't make sense, but the name of a class, right? An easy way to remember it is that I don't put the parentheses here. If I don't put the parentheses here, then I'm not going to put the parentheses here either. Okay? But those angular brackets, yes, I do need them. Why? Because you can never speak of an ArrayList. You can only speak of an ArrayList of something. You always have to specify. You have to give pretty much a concrete target to the data type E that we saw in the notation. Okay, the concrete data type that you pass is actually very important. In our case, what is that concrete data type? What should I put between the angular brackets? Yeah, audiobook. Very good. Okay, so what I'm saying here is I want to write a new class, audiobooks playlist v2, and that class is going to be everything an ArrayList of audiobook is plus more. That's the definition of inheritance, right? So that means that right now I inherited everything an ArrayList can do. So remember that slide and that table in the textbook that said, you know, you have an add method, you have a contain method, you have this, you have that, you have clear and whatnot, I don't remember. All of those methods right now are inside audiobooks playlist v2. There's also attributes, but I don't care about those, okay? I care mostly about the method here. So, all right, I got that done. So now let's see about finishing writing this class. I'm going to need a constructor, so public audiobooks playlist v2. That constructor is not going to take any parameters. And the only thing that I have to do right now is total duration equals 0. Initialize my attribute. I still don't have an ArrayList, or do I? Where is my ArrayList? I used to have a nice attribute list. Where is it now? Where is it stored? Well, in the class itself. You said, you know, audiobook playlist v2 extends ArrayList. So if I ask myself, you know, where is my ArrayList? Well, I am the ArrayList. The class itself is the ArrayList. You're going to see what that's going to imply, you know, when we try to modify the code there that we had before. So we have this nice little thing here for total duration. Let's go back to our audiobooks playlist v1, the original. There we go, audiobooks playlist. And let's steal some stuff. For example, here, I have an add method, okay? And you're going to see why I was asking that question of where is my audio list, okay? So I'm starting by saying, okay, this is how I wrote the add method in the original audiobook playlist, the version 1. How do I modify this for version 2? Because if I try to compile this, it's not going to work very well, right? So it should complain about a bunch of things potentially, but here it's complaining about error add, return type not compatible. So yeah, the add method, I haven't messed with it yet. It's because it's overridden. But anyway, what else? We need to take out the letter B. But if I do that, how am I going to get my parameter? So I want to get a parameter. Okay, this is what I want to add. And then I want to add it to the playlist. Yeah?
So would the parameter be the array list of like audio clip?
Yes. No, well, not the parameter of the method, but I will have to use the array list. This is the old version. The array list was an attribute, right? Called list or playlist, actually. In this version, it's called playlist. In the version that we did live, it was called list, okay? So this is the attribute of version 1. I don't have it anymore. I didn't declare any attributes here that were of type array list of audiobook. Instead, I said, I am an array list of your audiobook. So when I call this method add on an object of my class, this object is not going to be able to say, oh, you know what, you want to add something? Yeah, sure, I have a list attribute here inside of me. I'm going to pass the add request to that attribute, and the attribute will do the job because it's an array list. Now, the object on which you call the add method, the one that we're writing right now, this is the object that is the array list because its class inherit from array list. So what do I replace this word here? What do I replace it with? It's one replacement of one word. That's the hard part. No idea? Okay. All right. Okay. So that means this is a good example for us to work with. Okay? Because there's one more thing I need to click in your mind so that the whole picture starts making sense. What if I write this, literally? Take a minute to think about the implication pretty much. Does that make sense to you? Why do I use this? Yeah.
Because isn't it going to, Java's going to look for, so we're calling .add.
Uh-huh.
It's a method you can only use on array lists, like variables.
Yeah.
So it's going to use bit.add, it's going to look for the first one, the first like array list variable you have.
Well, it's not going to look for it because I'm going to point it to that variable, but you are like on the right track, right? When I write, does that make sense to everybody? When I write des.add, what does that mean? That means that you remember des is a reference variable that points to the object, right? That on which this method add is running right now. So you call the method add, this one here, the one that we're writing. You call it on an object of class audiobook playlist v2, the class that we are writing together, okay? So I tell that object, add an audiobook to your playlist. And the object says, the object, me, is who is going to do this add operation, but I'm going to use the add from my super class. The add that I actually inherit. Does that make sense? So why don't I use super here? Uh-huh.
And not the array list class.
No, I wouldn't go that way because, yeah, there's a subtle distinction, but we haven't covered that. So, yes, we are extending the array list class, and more specifically, the array list of audiobook class, okay? You would say we're extending the generic class. There we go. Audiobook, that would be 100% correct, okay? So, in this case here, I want actually to use that method, but since I inherited the method, I have access to this method. So I can, if I want, write this.add b, and it's going to call the add method on myself. Which add method? Well, the one that takes an audiobook b, and so on and so forth. Okay? If I wanted to do this instead, super.addb should work as well. The bottom line is we are going to let our inherited version of the method do the job. Okay? All right. And then we are going to add the total duration here and stuff like that. So let me check real quick. One quick thing I need to modify here. So I had to, there's a missing return, so I'm going to take care of that real quick. But I had to change the return data type. Why? Has to do with overriding. Yeah, sorry?
Because the super method add is a Boolean.
Yes. So that was that weird quirky thing that I pointed out, when we were looking at the method for a release. I told you this is a little weird, but the add method returns true or false, depending on whether it actually was able to do the adding or not. Okay? So I'm kind of like writing a bastardized version here because I'm going to return always true. So my version is not going to be, thread safe or good for concurrent programming. It's just going to be a basic version. But what I'm doing here, what I changed, is I changed the return type because the compiler kept telling me there's something wrong here with your return type. It looks like you're trying to override the add method, but yeah, it's not working out. Well, yeah, in the previous class, I was not overriding add. In the previous class, I was not inheriting from anyone but object. I was writing my own add method, and I was playing with it pretty much. Here, when I cut and paste this code, the first thing that didn't work out is the fact that, I could not call add on the attribute list anymore because it wasn't there. And the second thing that didn't work out too well is that this method was returning void. That's the one that I crafted, for my other version of the class. Well, when you inherited from array list of audiobook, you got the add method. But that add method returns a Boolean. So there was a clash here between my method looking exactly the same and returning nothing, and the other method looking exactly the same but returning a Boolean. So I had to adopt, pretty much what my superclass was doing. So I said, I'm going to return a Boolean. By deciding to return a Boolean, now it's a clean overriding. Okay? This method here, this line here actually, is exactly how the superclass expects me to declare an overridden add method. Okay? And then I'm going to call the method that I inherited because I don't want to redo the job, reinvent the wheel. And then I'm going to add to my total duration the duration of that audiobook. That's my bookkeeping. And then I return true. Yeah.
So why can't you use list.add or playlist.add?
So I can't because it's not defined here. So what I did is I replaced, private list, array list of audiobook. Okay. I replaced this as my container by the fact that I inherit from audiobook. So by this. Yeah.
So by inheriting from array list of audiobooks, so if it's all the methods and attributes that were defined for audiobook?
That were defined for array list of audiobook.
Okay.
When you inherit from class faculty, you get all the method and attribute from the class faculty. If I inherit from something that is not as trivial, but just barely a little bit more complicated, which is array list of audiobook, it's a class that has those angular bracket, then I get all the method and all the attribute from array list of audiobook.
So they could appear in different classes, such as audiobooks and audiobooks playlist?
So you keep mentioning audiobook, but that's what makes me uncomfortable, because audiobook is just the element that's inside the playlist. Okay? So what I want to make sure we're on the same page to both of us, okay, is that audiobook playlist V2, this class here that I'm writing, is not actually a new version of audiobook. Okay? It's just a new version of array list of audiobook. Like sooner you were saying, we inherit from array list, and I kind of corrected you, but maybe this is actually a good entry point for everybody to understand. Yes, you do inherit from one version of the class array list, which is an array list that is meant to contain audiobooks. Yeah?
So if you had, so when we do like the dot add method, and we print, that's gonna still print, it would still print just like if we did like list dot, or if we had like as in the first audiobook playlist that we made, the version 1, we had list, and then so if we were to, in that playlist when like we printed the list, is this one referencing that list at all? Like
Yes.
the list in that first audiobook, the same thing as this array list audiobook that we're inheriting from?
Yes. Like, for example, and this is why I started using the keyword des, and then I switched and I went to super, because super, I thought this is going to be closer to what you guys remember because of overriding, okay? But in that case, if I call des.add, I'm saying, this object that's being called right now, on which, the method add is being called, that's the one that is capable to act like an array list, okay? Allow me to take a stupid analogy. I love stupid analogies, okay? Let's say that one of you is a certified public accountant, okay? I have a little business. I want us to do our tax in a legal way. So what I'm going to do is I'm going to hire whichever of you is a CPA, okay? So analogy goes that way. I'm a class. I have multiple attributes. These are like the thing that I use to get my job done. So in the analogy, I'm a company and I have employees, right? And then I have to have an employee, an attribute that is a certified CPA, to be able to ask it to do my taxes. Every request I receive about, how much do you pay in tax this year? Ask the CPA. What is going to be your filling for the form, blah, 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 this year? Ask the CPA. I forward everything, right? The CPA is my attribute. The second version that we did of the class, I'm still a class that represents a company. I have maybe some attributes, that represent components, tools that I need to use for my company to survive, personnel, resource, assets, etc. But now, I said that I am certified as a CPA. So all the knowledge that somebody who is a CPA has is in me. I know how to complete taxes. I know how to compute whatever I need to compute to complete them. So now when you ask me, how much are you going to pay in tax this year? Instead of looking in my attributes for a CPA and passing the request to them, I have inherited all of the method, attributes, and tools that I need to answer the question myself. So I can trigger those methods, I can use those attributes, and so on and so forth. That's exactly what's happening here, okay? Instead of delegating to the attribute that is actually, an array list of audiobook and telling it, okay, you manage this. Here's an audiobook, shove it somewhere in your array list. Well, now that I said I am an array list, I have the add method that attribute was going to use. It's just that I never had to write it. It was inherited. This is what throws off some student every semester. This is, like I told you, this is a little, details, a little cherry on the cake. If there was any sort of blurry understanding, fuzzy area, in your understanding about inheritance, then just putting the cherry on top is going to collapse everything, right? But that's okay. We're going to rebuild it now. You see how what I meant by inheriting means you get all the method, all the attribute. You see what I meant when I said the relation inherit from in object-oriented programming parlance is also called the is a kind of. Okay? My class audiobooks playlist V2 is a kind of array list of audiobook. Well, I'm a kind of array list of audiobook. So I do everything an array list of audiobook does, plus more. So if you want to add something to an array list of audiobook, I'm your man. Okay? That's it. That's pretty much like again, nothing new really, but just applied in a weird way that makes you think about, okay, what have I been doing all along with inheritance really? That was I would say the most important part, okay? So I'm going to go a little faster on the rest. What about toString? Well, I can write the class toString. So remember that this audiobooks playlist class had to feature a toString method. Here's my toString method. This is the only thing that I modified. The previous version said, for each audiobook be inside of the array list. That was my attribute, right? Well, forget it. Now this version is the array list, so I say, for each audiobook be inside the array list, this. Myself, the object that's being executed right now, right? So, same logic, right? Same logic than before. Except that here, it would not really make sense to use super instead. The previous one, we had a choice. We could use super, we could use this. Here, you have to pass this array list. It's a for each loop. It wants to see the array list itself, the array list object. I'm the array list object. Last one that we had to do, and I don't know why I have a slash here. It looks like I have an extra curly brace as well. Must have been cut and pasted. And the last one that we have to talk about is get total duration. And get total duration is really similar to string. Okay, you've seen that when we did the live coding last time. And the modification to get total duration is going to be very similar to the modification that we just did to string. Okay, so I just need to say now when my for each loop say, okay, I'm ready to iterate on your array list. Where is it? Is it in an attribute? No, I am the array list. So this is this. So we are stitching together this, super, overriding, inheriting. It's kind of like everything is coming together in this example, right? So these are the good times for learning. Good time for learning because, again, that means that anything that you might have missed in any of those topics now is going to cause you problem. Brute force through them, okay? Work through them, don't give up, don't skip, don't overlook. Yeah?
For the give total duration method, wouldn't we just return the total duration? Because in our add method, we add the total duration every time we add something to the list.
Oh, you're right. You're right. I think I made an hybrid between two versions I had. Sorry, this is my fault. I made an hybrid between two versions I had. One where I was just not, accumulating in total duration, and one where I was accumulating in total duration. So, yeah, the remark is perfectly valid here. Here's a simpler way to do this. Remove all this. Total duration, because like you said, we add every time we add a book, we add to the total duration. So this is even easier, okay? But that one is less fun. All right. I have a very weird definition of fun sometimes, but anyway. So, yeah? Absolutely. There we go. So use this example. Okay, like I said, don't give up on it. Okay, you have all the tools to understand it. But it's going to take a little bit of effort, to align everything in your mind, get like a different picture maybe than the one you had until now, and then it's going to click, I guarantee you. If it doesn't click, come to office hours, we'll help you, we'll make it click. Yeah.
So just once again, so we inherit from array list of type audiobook. So, and we get all the methods and attributes for the class array list.
Correct.
And so that's how we're able to override these methods?
That's correct.
Okay.
Yeah. You are able to override the method add because you inherit it from, array list of audiobook. And then in toString, for example, I'm capable to point my for each loop to this myself because I inherit everything from array list. So I am the array list. Okay? It's making sense? Cool. Awesome. So you had a question and then you?
So if we ever needed something like this, we could just basically extend an array list of whatever element we need
Yes.
of whatever object, instead of saying like, oh, the list equals new array list of that element or that object. So
Yes.
it's kind of like a new declaration.
So it's not a new declaration, but what you just did is you just started the war between inheritance and composition. Because your remark was, so everywhere I did composition before, now I could do inheritance. And I would say in languages that have multiple inheritance, yes, you could go that far, okay? Because you could say, if, instead of having an attribute of class A and an attribute of class B, well, if as long as I have only one attribute of each, I could say, I am a class A, I am a class B, I am everything, right? You would show its limit very soon. For example, if instead of one attribute of class A, you had two of them, then inheritance cannot help you. Because it's like instead of having two class A attributes, I'm going to say, oh, I'm a class A attribute. But I thought you needed two, so who is the other one? So then you would be mixing inheritance with composition. That could get very ugly, okay? But you still touch, to a very, touchy topic in object-oriented programming, which is, which one do I use? If I need one attribute of class A, am I better off doing composition, so having an attribute of class A, or am I better off inheriting from the class A and being the class A myself? And the answer vary. Okay, originally the trend was use inheritance everywhere, and then why not use multiple inheritance, etc. For the last 10 or so years, 15 years maybe, I don't know, I lost track, the trend has been, okay, let's calm down a little bit with inheritance, because inheritance is kind of difficult to control sometimes, to master. So we have a tool that's called composition. If you just need, for example, in my analogy, if you just need to hire a CPA, don't go through the training to be a CPA yourself. If you are the CEO of your own company, you're not going to become certified in CPA, certified in Network Plus, certified in this and this and this. No, you want to surround yourself with a team that can help you. That's the idea of composition. Okay? You had a question too?
What is the start dash
Oh, it's just nothing. It's like doing, like a symbol for a list. Like a dash in front of every element of the list, or a star in front of every element of the list. It's not a special syntax. That's what I'm trying to say. Yeah. Yeah? Can I show you the add method? Yeah, absolutely. Let's go back. There we go. So the last version I went with is calling with this, because this is what I do in the other method as well. Okay? Question or just stretching?
So
yeah.
In that first audiobook playlist, we declared like list equals new array list. If we never did that and just wrote our class like this, it would still do the same. It would be
yes.
Okay.
Yes. So very good question. In the previous example, when we had an attribute of type array list of audiobook, we had to create that array list of audiobook. We had to say new, right? At some point, new array list of audiobook. We haven't done that anywhere here. So how come the array list comes into existence? Okay, when we say the class audiobooks playlist v2 extends array list of audiobook, okay, that means that whoever is going to create an object of class audiobooks playlist v2, when they do the new, audiobook playlist v2 parentheses, etc., when they create that object, they also create everything that is in the class of that object, and the superclass of that object, that would be a array list of audiobook, and the superclass and the superclass, okay? Remember, you create an object of class A, you have to create the whole thing. So if A is a subclass of B, which is a subclass of C, which is a subclass of object in Java, when you create an object of class A, you have to call all of those constructors. You have to create all the attributes from all of the superclasses. Okay? That's what's happening here as well. So when I said audiobook playlist v2 is a kind of extends, array list of audiobook, now when you create an audiobook playlist v2 object, that object has everything the array list would have. So the new has been done at that moment.
Okay, so it's basically like for every audiobook playlist v2 we have, each one of those has its own array list.
Yes,
Like
inside.
That's when it creates it, when it
Yeah.
calls the constructor and all that.
If you look inside the code for the class array list, you are going to find an attribute somewhere there that the ArrayList class uses to store data. It's probably going to be a basic Java array, or it's going to be maybe a linked list. I don't know what data structure they use, okay? But the bottom line is you are going to have some attribute that stores the information inside the ArrayList. Well, I have those. And they're all private, and nobody cares about them. But the only thing I care about is that the same way that I could add by asking an ArrayList object, another ArrayList object to add something, now I can ask myself to add something, and it's going to go somewhere and be stored in the ArrayList that is like in my inard, okay? And all of this is private. So we go back, there's a good example. We go back also to abstraction, encapsulation. I just said I am an ArrayList, but did that force me to actually read the code of ArrayList, understand it, understand all the little detail, etc.? No. All I had to worry about is by saying that I am an ArrayList, a type of ArrayList, what are the features that I gain? What are the public methods that now I can use on myself, that others can use on myself? Add, for example, remove, clean, clear, all of that stuff. Yep, and that's it. That's all I need to understand to be able to become a new kind of ArrayList. Does that make sense? So even if you're not 100%, like comfortable with this, don't worry. It takes a little bit of time, but ask question, Piazza, come to office hours, okay? This is a very good example. This is a milestone. For you to understand this and be able to do the practice exercise, then you're going to be okay. Yeah?
Can you just show the get total duration by iterator method?
Yeah, absolutely. So I kind of like simplified it a little bit. Did you want to see the whole version?
Yeah, the whole.
Yeah, all right. Let's see if I can undo the changes here. Yeah, we should have enough in the undo buffer. There we go. Get total duration. This is the version. And that one mimics toString. Okay, it's the same structure than toString. And it's been the same modification to it. Replace, the des keyword and so on. All right. So, with this being said, all the practice exercises that I released until now, that are in the slides, are like free for all now. They're like fair game for you to tackle. Yeah, you had a question?
Can you test it?
Yeah, absolutely, yeah.
Put it to the test. Mine got a
Okay, so it compiles, run it. I don't remember exactly what we inserted here, but let's just go and figure it out together. I have a first. No, actually, you know what? I'm not even using this yet, I think, in the main. So let me go back to the main and see what we are doing here. So inside the main, I create a first version of the audio playlist, a Promax version of the audio playlist, and then I have, there we go, a version 2 of the audio playlist. So I'm going to comment all this just for sake of clarity, so that I don't need to see the testing, of the audio playlist version 1 and then the Promax audio playlist. I just want to see the testing of the audio playlist version 2. And this is how I test it, okay? Create an object, add a bunch of, same thing that I was doing with the other one, add a bunch of objects of class audiobooks inside of it, then display the whole list, and then display the total duration. Compile, run, and there we go. So I have 1, 2, 3, 4 books in that thing.
Isn't that what's using the first audiobook playlist stuff? Because isn't the class called B2?
Oh yeah, you're absolutely right. What a cheat. Okay, there we go. Ah yeah, we get something. Incompatible type, so let me take a look at what it's saying exactly here. Let me hide this. There we go. So incompatible type, audio playlist, playlist to audio playlist. Yes, it's because, yeah. Yeah. So we are going to talk about that exact topic, by the way. Probably not today, but next lecture. Like the conversion like that, yeah, they don't happen by themselves.
It says B2R.
Yeah, thank you. All right, so compiles, run, and we have a Stack Overflow because I am calling recursively here. So in this case, yeah, I need super.
Okay.
Yeah, that's what you are getting to? Yeah, it's because I made it like trying to switch back and forth between the two, show how equivalent they were. Well, I made it to the point where we were calling ourselves pretty much. So there was an infinite loop, a recursion here. But if I use super, yeah, we're good.
So there's always, does that go for the two-string method as well, change the this to super?
No. They are slightly different. So this one is a little bit more constrained because I'm overriding. Okay. The other one is not as constrained because I'm not overriding. Yes. Go to the main? Absolutely, yeah. Let me make that bigger too. There we go. This is a part of the main that is testing that new class.
So why was it different in
The des and super?
Yeah, why does the difference matter in the add but not in the two-string?
So the difference matters because let's start with the two-string. The two-string, you say, I have a for each loop, and that for each loop needs to be told where the array list is. So in that case, I say des, it works. Okay? In the other version, what happens is that I am overriding the add method. That's the keystone there, okay? I am overriding the add method. And then inside the add method, I do des.add, which means call the add method, on yourself. And since I'm overriding it, I'm calling myself. Why do you keep on hitting yourself? And yeah. When I do super, it breaks the ambiguity pretty much. It says, no, I don't want to call the add here that I'm writing. I want to call the one from the super class.
Okay.
All right. All right.
So we don't override the two-string method here.
No. We do override the two-string method, but we don't try to call it. I didn't do anything like super.toString or stuff like that, right? So if I was trying to do that, if I was trying to call the two-string method from inside the two-string method, then I would expose myself to the same kind of problems, ambiguity, etc. But here, in the two-string method, yes, I do override it, but I throw away the old version. I don't even try to call it. I don't have any recursive call. It's clean. Well, I don't know if everybody clicked on this, but you guys certainly had very, very good question this morning, so I'm happy about that. Okay? So, all right. Let me go back to the slides now, and I need to rewind a little bit.
And then one more question.
Yeah, sure.
For the next playlist, or for the Pro Max audio playlist, everything would still work except we would just extend playlist V2 so that we wouldn't
yeah. So hold on, let me think a minute to see if anything is going to blow up there if we do that. So the proposition is, what about we rewrite Pro Max, and this time we make it extend? That should work.
I think we would just have to change instead of putting list, we could just
Yeah.
put this.
Yeah, but in the Pro Max one, do we even have this in the Pro Max? The list. Yeah.
When we do two-string by narrator, we check each narrator in every.
Let me check real quick. Yes, we use this list or playlist argument, so we would have to update that. Absolutely.
And that's
Yeah.
maybe the only difference that we get.
Yeah, well, except that now that we need to access this, you know what? Let's try it. Okay, we'll try it between this lecture and the next lecture, because I'm wondering if we are going to bump also into a visibility modifier problem if we do that. Okay, that's the only thing that I'm worried about. Everything else should be okay. It's just I wonder if we're going to have a visibility modifier issue right here. And I don't think so, because we call this, so we call ourselves, so it's going to find the method. Yeah, that should work. Okay, but I always take it with a grain of salt when I say that should work until I write it and it works and it compiles, etc., and everybody can replicate it, then it's should. Okay? All right. So now we are ready to turn like a big page actually in this module. We're going to switch to polymorphism. So we are done with the basics of inheritance, and for the IE that's coming up at the end of the week, the topic is basics of inheritance and array list, using an array list. Okay, not extending the array list class. Just want to make that 100% clear for everybody and have it in the recording as well. So now we are going to start talking about stuff that's going to be the last stretch, the last segment in our module M3. This is not going to be as an exam either for this week. It's going to be probably as the next exam. Okay, I'm still trying to determine how much polymorphism I'm going to put in the next IE, which is going to be called IE03B. So the goal here is to define that concept, polymorphism. What does it mean to have polymorphism? We're going to spend a lot of time defining the concept, look at some examples. It's really not that much new stuff. It's kind of like defining a term, defining a new terminology. However, it's another one of those things that goes back to everything that we've done in inheritance so far, and that kind of like takes you by surprise by switching the perspective a little bit. So by the time we are done revisiting again and again and again and again that very simple definition of inheritance, now you see why I told you inheritance is simple to define. You know, I get a copy of all the method and all the attributes from my superclass, but it's what it allows to happen that's so interesting. Okay? And polymorphism is probably one of the most important and interesting things that happen because of inheritance. So for this part of the module, and we are going to come back to that slide next lecture. I have a copy of that slide again. So I just want to tell you, we are going to have 2 practice exercises for this part of the module. Okay, just for polymorphism. And what we are going to do is we are going to revisit again to-do list. We are going to revisit again invoice. And I'm going to give you the gist of what I want you to do, and then come to office hours and we'll refine that and we'll help you, okay? But the gist of what I want you to do when you get to those practice exercises is, instead of having one kind of invoice item, we are going to have, let's say, 2 class invoice item. Okay, we are going to have like the basic invoice item, then we are going to have a subclass of invoice item that is an invoice item that has some additional feature. So for the to-do list, for example, the things that are suggested is you have your to-do list, you have your to-do class that represents a to-do item, and I want you to create a subclass that is to-do item with priority, and another subclass that is to-do item with assignment. The priority means that you just have an int inside the class, that you use to keep track of what level of priority your to-do item is at. And the other one, assignment, is going to have an additional string as an attribute that allows you to put the name of somebody to whom this to-do task is assigned. Yeah.
This is for IE4?
That's going to be for the next IE, absolutely.
No.
Okay? Not for this one this week. No. I want that to be super clear so that you guys don't freak out, because this is going to be a lot of new stuff. Okay? So, yes, definitely, by the time we hit the final, by the time we hit the next IE after the one at the end of this week, we are going to start doing things like that. So those exercises are going to be good pattern as well to prepare you for the following IE and for eventually the final. Okay? So, again, the gist of it is, instead of having one to-do item class, you're going to have to-do item, and then you have to have a subclass to-do item with priority, a subclass to-do item with assignment. And I kind of explain what's going to go in there. So now we are in a situation where it's kind of like the audiobooks and stuff like that, and we are going to still use the audiobooks example also in this module. It's kind of like the audiobooks and ebooks and books, right? We have multiple classes. Some of them are subclass of another class. And if we wanted to store list of those things, like array list, for example, right now with what we learn to do, the only thing we can do is I can have an array list of to-do items, or an array list of to-do item with priority, or an array list of to-do item with assignment. The same way that, remember last lecture when I told you, here's a little exercise that you can do for fun and practice. Take the book, audiobook, ebook example, and in the main, make an array list of book, an array list of ebook, an array list of audiobook. These are 3 different lists. Sorry. Why do we have to have 3 different lists? Because the goal, the rule with the array list was, it's an array list of something. You have to specify a type. So if I say it's an array list of books, all I can put in there are books. If it's an array list of audiobooks, there's going to be audiobooks in there, and that's it. If it's an array list of ebooks, and so on and so forth. Okay? Well, we are going to bend that rule a little bit now. And this is what's going to allow us to do those exercises. And in those exercises, you are going to end up with an array list, that's going to contain, so for the book example, book object, or audiobook object, or ebooks object, all mixed up together. So I can have 2 audiobooks, 1 book, and then 3 ebooks in the same list. And for the example of to-do list, in the same to-do list, array list, I'm going to have a to-do item, a basic to-do item, then 2 to-do items with priority, then 1 to-do item with assignment, another to-do item with priority, and I should stop moving that way, and then so on and so forth, and I'm going to mix and match like this, okay? So how are we going to be able to do this? Just because of this definition of polymorphism. So polymorphism is not something we are going to add. It's something that, again, was there all along. The first time we started inheriting, we had polymorphism available at our fingertips. We just were careful to not use it until you guys got some experience with inheritance, basic inheritance. And now that you have had experience with basic inheritance and array list, now we can unleash pretty much the full potential of inheritance. So what is the definition of polymorphism? A reference variable meant to hold a reference to an object of a given superclass may refer to any object of any of its superclasses. So what does that mean? That means when I declare a variable and I say that variable is a reference variable of data type book. Let's use the book example because it's kind of fresh in your memory, okay? So when I say this reference variable is of type book, for example, then that means that inside that reference variable, I can store a reference to an object of class book. Duh, that's what we have been doing all along. But I can also store a reference to an object of class audiobook, or an object of class ebook. Why? Because audiobook and ebook are subclasses of book. All right? Example from the textbook. We have a geometric shape class. It's our superclass. And then we have a subclass rectangle, a subclass circle. So I define 3 reference variables. Ref, that is a reference variable meant to hold the reference to a geometric shape object. Rectangle, which is a reference variable meant to hold the reference to a rectangle object. And circle, which is a ref variable meant to hold the reference to an object of class circle. And by the way, why have I been so pedantic since COP2513? Why did I say this is a reference variable meant to hold the reference to an object of that class? Because now we are discovering that even though ref, for example, is declared in a way that means I should have a reference to a geometric shaped object, the polymorphism definition tells us that it may not be the case. I could have a reference to an object of a subclass of geometric shape. And that's exactly what I do here. So rectangle, I create a new rectangle. Circle, I create a new circle. So right now I'm just doing what I've done so far, okay? And then I assign to ref the reference inside of rectangle. So until now, what was on the left-hand side of an assignment operator and what was on the right-hand side of an assignment operator, until now, they always had to match. If your variable is a ref variable, declared of class A, then you're going to create an object of class A and put the reference inside the variable. Now we're changing that rule for reference variable. Now we're saying if you have a ref variable of class A here, you can always create an object of class A and put the reference in there. But if you create another object of class B, and it so happens that class B is a subclass of A, then it allows you to assign that reference as well to ref. Okay? So it's another one of those things. It's really, really powerful. Because now we say everywhere we declare those reference variable, right? Everywhere we declare reference variable, now we can have polymorphism. All it takes is the data type of that reference variable has to be a superclass, something that is a superclass to something else. And now we enabled, all of the subclass types, to be passed as parameter or to be set to an attribute, because that's the deal, right? When I declare a reference variable, it can be a local variable, it can be an attribute, it can be a parameter. So all of those situations right now, I can now have polymorphism in all those kind of variables. So of particular interest to us is going to be the case of parameter, because parameter is going to be what we're going to use to kind of introduce the basics of polymorphism. So when I write a method, if I say my method take as parameter, an object of class A, well, now by definition, if the A has a subclass B, then I can receive as argument, when the method is actually called, I can receive as argument reference is to object of class A, or reference is to object of class B. Okay? All right. Let's take an example, and we're going to finish with this example probably. Actually, no, we have a little bit of time, so we might be able to do 2 examples. We have a geometric shape, a circle, and a rectangle. So superclass is geometric shape. Circle and rectangle are the subclasses. Let's write a polymorphic method. So bear with me. We are leaving on the side a little bit, what we have been doing for the last few lectures. We are going back to writing a very basic static method in a class that has a main. Okay? Why do I revert back to writing a static method? Because we don't need any more than that to show you polymorphism in action. So I'm trying to find the simplest scenario illustrating polymorphism in action. So, public class polymorphism demo. All right. Inside of it, there's going to be a main somewhere, but more importantly, there is public static void display object, and it takes as parameter a geometric shape object. Okay, object is the name of the parameter, geometric shape is its data type. And inside of it, I do system.out.println. This object was created on object.getDate created. So I'm assuming that I have an accessor, okay, in that class geometric shape that gives me the date it was created at. And then the color is object.getColor. Again, I'm assuming I have an accessor in geometric shape that tells me the color. So it's very similar to the previous examples we did with a class named geometric object. Okay, it's been renamed in the textbook here as geometric shape, but it's pretty much the same thing. All right, this is going to be what we call our polymorphic method. Why do we call it a polymorphic method? Because one of its parameter is of a data type that has subtypes. The geometric shape data type, the class geometric shape, has actually 2 subclasses, rectangle and circle. So that means that there is potential for polymorphism to happen here. That means that because that method has one parameter that is potentially polymorphic, we call it a polymorphic method. Here's the main. I call display object twice. And I'm going to create an object and pass it immediately as argument. Okay, I'm not even saving the reference in a variable. I'm just creating it on the fly, calling the method, giving it that reference. So what we have here is display object, and I call, let me get the laser pointer here real quick, and I call here new circle 1 red false. So 1 is a radius, red means the color, false is a boolean that says whether when we display that circle on the screen we want it to be filled with a color or not. So I create an object of class circle. I pass the reference of that newly created object as my argument to the method. So this method is going to get a parameter object here, and object is going to be set to the reference to that new object. Here's the problem. Object was supposed to be a geometric shape. I'm creating a circle. Is that okay? Yes, because everywhere you expect a geometric shape, you will accept also its subclass, like circle and rectangle. And that's what I do here next. I call display object, and I create on the fly a new object of class rectangle, and I pass it to the method. Again, this argument is going to be a reference to a rectangle that's going to get assigned here to object parameter. The object parameter was supposed to be of type geometric shape, so the types do not match, but it's okay because the 2 types are related by inheritance. Geometric shape is a superclass of rectangle. Where do those methods come from?
The the geometric shape class?
Yes, the geometric shape class. It's important because what you said here when you declared your polymorphic method is my method is going to work as long as you give me a geometric shape as parameter. And because we said that, the compiler is going to make us stick to our word. Okay, the compiler is going to check that every time we use the parameter object, like here, object.getDateCreated, object.getColor, the compiler is going to check that those methods we are trying to call, they are actually defined in the class geometric shape. Fair enough, right? How does that work with the fact that we pass a circle and a rectangle? Well, circle and rectangle are subclasses of geometric shape, so they do everything geometric shape does and more. So if I give you a circle or a rectangle and you are going to call methods of the class geometric shape on those objects, you guys are okay. You are always going to find getColor and getDateCreated in my object because my objects are of a subclass. Question?
Where would the visibility modifiers make an issue here?
So here the visibility modifier would not make an issue because you say your parameter is geometric shape, you call method of type geometric shape, no problem. Good question. All right. And this is where we're going to start trying to break things, okay? So this is the most basic example of polymorphism. That's what 99% of the time you're going to encounter this kind of example. But then, if you understand this, we can stretch it a little bit more. There are other things that we can do with polymorphism that are based on what you just understood. So let's have at it. The question that I'm going to use to kind of articulate, how we are going to look at those extensions is the following. What would happen if we called methods that are overridden by the subclass? Because right now, the two methods, getDateCreated and getColor, they are methods of the superclass. So you say my parameter is of the superclass type. In the code of your method, you only use methods from the superclass type. It's kind of a clean situation. Okay, you said you were going to work with a geometric shape. You call method from the geometric shape class on that object. We are okay. It's perfectly clean. But now, let's start to throw a wrench in that situation. What if the subclass circle had its own version of, for example, getColor? What if the subclass rectangle had its own version of getColor? What if they decided, for whatever reason, to override, this method? So which one would be called? Would it be the overridden version? Would it be the version from the superclass? So now the situation is a little bit more complex. That's exactly what we are going to have to deal with because of polymorphism. Okay? Introducing polymorphism, just like introducing inheritance, opened up a lot of side effects. Introducing polymorphism, allowing to pass, to assign references, of a different data type to a reference variable, as long as the different data type is a subclass of the original data type. This is going to introduce the need for another mechanics that we're going to explain right now. So here's another example. We mentioned that example one time, I think, so it was just mentioned in passing. Is a person, is a superclass of student. Student is a superclass of graduate student. Okay, so that's what we're going to use here in our example. And we are going to have a little piece of code here where I'm calling in the main a method called M. The method M is written here. So public static void M. Again, it's a static method, okay? Nothing special here, nothing like we don't need to create an object. We just call the method directly from anywhere. It's fine. Public static void M takes as parameter an object X. And then it uses that parameter X to call toString on it and display it. So, quick recap here before we go even any further. Why did I choose the parameter of type object? And I already introduced that to you. What's the object class?
It's the super class.
Super class. This is actually the one class in the entire Java system that doesn't have a superclass itself. Every other class has a superclass. Okay? So every class that says extends blah is a subclass of class blah. Okay, no problem there. It's explicit. If you write public class circle and you don't extend anything, you don't use the keyword extends yourself, then by default Java assume that you extend the class object. So most of the class that we wrote before to discover inheritance, they were subclasses of object. Every class in the JDK is an indirect or direct subclass of object. This is where we put all the stuff that every class in the system needs to have. And then the class object itself doesn't have a superclass. This is the only exception in the entire JDK. One class doesn't have any superclass, it's the class object. All right, so going back to our example, by putting object here, I'm pretty much opening my method like super wide. Okay, my method can take, in practice, you can pass me an argument of class object or an argument that is a reference to an object of a class that is a subclass of object. But I just said that every class in the JDK is a direct or indirect subclass. So you can pass to this method any reference of any data type. You can pass a faculty, a student, a to-do item, an invoice, an array list of cucumbers. I don't know. Anything that is an object in Java, anything that is a reference to an object can be passed to that method because I opened wide and I said, I'm going to accept object reference and any of its subclasses. So this is as close as we can get to writing what I would call informally generic code, without having to learn, what generic really means in Java. I would call this still some generic code because this method will work on anything. You give me a reference to any object, and what I do, I call toString on it. Here's what I do, for example, in the main here to test this out. I call the method m several times. One time I call it on a graduate student, so I'm using that little class hierarchy that I had on the previous slide. I call it one time on a graduate student, one time on a student, one time on a person, one time on an object of class object. Never did that before, I don't think so, creating an object of class object. There's not much you can do with those, but in my example, at least it illustrates the point, that you can even pass a reference to an object of class object. And then I pass all of those references to m, and every time m takes the reference happily and calls, actually, toString on it. Where does the method toString come from? It's defined inside object. So again, object x dot, the name of a method that is defined in the class that you used here. This is a clean version of polymorphism. Okay? Except that I tend to override toString. We've done it several times. We are going to keep doing it. Most Java programmers override the toString method and override the equals method. These are probably the two methods in the whole of Java JDK that are the most often overridden. And they are both inherited from object. So what happens if I do x.toString here? Is this going to be always the method toString that is written inside object that is called? And the logic for it would be that I said x was an object. Okay, so x is an object, x.toString, okay, I'm calling toString from the class of x, which is object. Or if somebody passed to me at runtime, if they pass to me a reference, to something that is, for example, a faculty, and that faculty has a method toString, they override toString, well, then I have an option, right? I could say, yes, I'm going to stick to the version in object because you wrote object here. Or I could say, listen, you told me x was an object. But now when I look at the reference x, it shows me an object in memory that is of type faculty. So it would make sense also that I use the toString method that is defined in the class faculty because that object actually happens to be of type faculty. That's called dynamic binding. Dynamic binding is what Java does at runtime while your code is running. It tries to find which version of the method needs to be executed when there are different options available like so. Okay, until now, that dynamic binding happened all the time. It's there since day one in Java. But until now, the answer was always straightforward. Now we are trying to explore cases where, we could make a rationale for going one way, could make a rationale for going the other way. So we need to know which way the Java JVM is actually implementing dynamic binding. What are the rules? What are the policies here for it to choose which method to execute? So here's an example where we have graduate student extends student, student extends person, person extends object, and then I have a toString version in each of the class here, and of course I have a toString version in object that just displays the name of the class at and a reference. And then, so each of them has its implementation, and then I have a main method somewhere that is going to call the M public static method here that takes a parameter of type object. Okay? So, at runtime, we need to make the decision, what are we going to run? And this decision that is made by the JVM at runtime is kind of like intertwined with another thing that JVM has been doing for us. Actually, not the JVM, the Java compiler. Every time we write code, the Java compiler makes sure that if I write x.toString, that means something, right? That makes sense. So what I told you before is the compiler checks that x.toString, that the method toString belongs to the class of x. So yes, there are two different things that are going on, not exactly at the same time, one after the other. There's a check that happens at compilation time, and there's a check that happens at runtime. So this is where, like, what used to work without us worrying about it is suddenly getting a little bit more complicated. Okay? We have two different things, so let's give them names. The first one I'm going to call method matching. The second one I'm going to call method binding. I'm just going to give you the gist of it, and then we'll restart at this point next lecture. The gist of it is method matching is what the compiler does. You write x dot something, like the name of a method. I need to make sure I can find that method. So I look at the data type that you use to declare x. I look into that class, and I try to find a method, let's say toString. Okay? If I don't find one, you're in trouble. If I don't find one, you have a superclass, I'm going to search in the superclass. If the superclass doesn't have it, I search in the superclass. When I reach object, either I found one along the way, or I didn't. If I didn't, you're in trouble. Compilation error. If I found one, then I say, okay, your code makes sense. That's at compilation time. And then when you run your code, depending on what you pass as a parameter to that polymorphic method, the check said that whatever you pass, there's going to be a toString method somewhere. But now that you pass a specific object of a specific type, I need to figure out, what is the type of that object so that I can call the correct method on it. And that's dynamic binding. Question?
Question, are you going to upload this code later on, or?
Which code?
For the review.
Yes, absolutely.
Okay, perfect.
Yeah, the code that we did as live coding at the beginning is going to definitely be uploaded. So I'm going to stop the recording right now. We are done. Like I said, next time we'll restart pretty much this definition. Thanks for listening.